Right now I'd like to present the application 3. It's a hardware controller CB2CED. So it's pretty much the same that we were doing on the application 2, but right now instead of controlling something with the console, we'll be controlling something in the board using the switches and the push buttons. And we're going to use the same stuff that we were using before: the single shot, the CB2CED, and the top level VHDL that connect those two structures together. And we're gonna design a way in Vivado to bring the control to the board instead of the console. I'll be generating another IP block. It's gonna be called CB2CED hardware controller, and I'm gonna connect the counter and the single shot using the one VHDL file that I'm gonna call CB2CEPLSD, and then I'm gonna generate the hardware configuration necessary for this application and use the SDK to light the LED, and then I'm gonna use the SDK to implement the application on the board. So this is going to be the architecture for our project right now. We're going to have the PS block, we're going to have the EXA peripheral to connect the clock and reset together for both of this other block for my IP, and then we're going to create inputs and outputs directly to the board. And this project we're actually adding some constraint file as well. So it's something that I'm going to show you how to do on Vivado now. So we'll go for Vivado and create a new project. I'm going to call this one Zybo underscore CB2CED underscore hardware underscore control. Won't be adding anything right now. So go for boards, select Zybo, next, and finish. So we're going to create a block design. We're going to call Zybo, actually I'm going to call CB2CED underscore hardware underscore control. Okay. And now we're going to create another IP block. So go for create a new EXA peripheral. You don't have to change the IP repository file. It could be actually the same repository that you were using before. So I'm gonna call this one CB2CED hardware control. So hit next, and I'm gonna edit the IP now. So we're gonna do something similar that we did for the very first IP that we designed. We're gonna add sources, and it's going to be the exactly same three files that we did at the other time. So CB2CED, PulseD, and the single shot. So finish here. Should have the files here. Should see the hierarchy. They're ranged for each other. So just merge the change now. So we're going to open the top level now, and we want to create some ports. So you see this space here where users to add ports here, users ports in. So we don't need to create clock and reset because the Vivado create this automatically here. So what we need to add here is a switch, which is actually input standard logic type. We're going to add a up, which is also an input standard logic. We will have chip enable output, which will be an output standard logic. And we're also gonna add a count that will be an output standard logic vector 1 down to 0. So in here we create ports. So what we need to do right now is declare CB2CEPLSD as a component from this top file. So go for the architecture. Here you see a component from this other file. Go to the end, just add a component here. Just gonna open here because want to copy the entity. Here you go. And I want to paste here. So instead of end the name, just end component here. So right now we need to instantiate those things. We need to let Vivado aware of the port map of this thing. So we're gonna do something similar that we did, that Vivado did here. We're gonna call this one CB2CED PLSD underscore 0 as CB2CED PLSD. So port map now. I'm gonna paste again. Get rid of this. Rid of this line as well. And in here we have to map stuff from whatever they need to be mapped. Get rid of this. And I'm gonna add equals, greater than, and a comma. So I don't need a comma for the last one. And right now I need to port map this stuff correctly. So switch goes to switch, up goes to up, count goes to count, and chip enable output just goes to chip enable output. No great mystery in this. It's just mapping the ports with same name for your component to your top level structure here. And the clock and reset is a little bit tricky because we need to know whatever Vivado called them. So it's slave 00 XI a clock in every reset. So copy this. Now you select here and you paste it. So with this done, just gonna format some tests here and save the file. Oopsie. Just save, see if you got any change. You had critical warnings here. And yeah, don't end this, you don't need this in. Just get rid of this line, it should be fine now. Okay, so something's wrong with the declaration here of this CB2C. Yeah, right here on this structure PLSD. So I put a D on the front here and instantiate the stuff. So go back to your top level, get rid of this D here, get rid of this D as well. Save, as you see when the hierarchy updates, it should be fine now. So just run synthesis right now, see if everything is okay. And see if I have an error other than syntax errors right now. And if I don't have any, all I have to do is package my IP in use of Vivado. So synthesis completed. So go back to your package IP, get the merge files, go to customization GUI, merge the change as well. You see he adds some ports as inputs and others as outputs. Go back to identification, just put one here. .1 description. This is the CB2CED hardware controller, and the first update is add the ports to GUI. I'm gonna review in package your IP. Yes, so right now our IP repository should have a file, should have a folder for this project called CB2CED underscore hardware control, and I should be able to use this on Vivado. So I'm gonna cut this video right now because to Z-board, if you want to create the IP block, you could use the exactly same one for both boards. So I'm gonna cut right now and continue the design for Zybo and for Zed later on in other videos.